Okay, just a quick follow-up video because I'm getting a lot of comments about putting a capacitor across R27 feedback resistor. So as you can see, I have a 15 picofarad capacitor on there. And if we go up to the scope real quick and I turn on a square wave, I get some pretty nasty ringing. See that? Okay, let's turn off. Let it power down, bleed down. Okay, I am now going to remove this capacitor. And now we're going to go look at it with no capacitor. Okay, here we are. No capacitor. Beautiful, right? Here is a, that you can't see that it's out of focus, a 47 picofarad capacitor. Let's put it on real quick. I'm just going to tack it real quick. So 47 picofarads, that's not very much, is it? Across a 220K. Okay, let's power up the amplifier. By the way, you're looking at the speaker out right now, in case you didn't already figure that out. And what's happening? Feedback, or oscillation. So let's turn that off. It'll just get worse. Okay, so we're back to no capacitor at all. And you can see it's rock solid now. And if I turn on the square wave again, very little ringing. It'll sit there all day like that. So that's it. I just wanted to show you how this works. On this Hedge amplifier, the feedback circuit does not work like it does on a normal amplifier. The other thing is, I got some comments about the fact that a 6N1P is not a direct replacement for a 6DJ8 or E88C. That is absolutely correct. There is a Russian version that is a closer match to a 6DJ8. I do not have those right now. I have a bunch of these, so I decided to use them. For all intents and purposes, though, it is in the same family as the 6DJ8. It has a much higher filament current, so you have to make sure your filament circuit is able to accommodate that. There's a few other specs on the tube that are a little bit different, but for all intents and purposes, they're from the same family. I baked those differences into the schematic when I designed this. So really, that's not the issue. The thing is, the way this cascoded differential pair with a constant current source works is a lot different than what you might imagine it would work like. And there is a fine line between too much global negative feedback and not enough. So you really have to be careful. Let me shut the amp off so it doesn't just sit there and cook. So you really got to be careful how you design it. Now, understand, Morgan Jones just showed a concept SketchUp in his book, and then he abandoned the project because he went on and built what he calls the Crystal Palace amplifier, which was a fully balanced amplifier. So no one has really built this before. The one that Hedge built is a different design. It's a lower power. It didn't have an active constant current source. It just used a tail resistor. There were totally different tubes. There were a lot of differences between his design and this one. This is something that's very unique. Again, coming back to my first video, I have always wanted to see if this concept would work, and it does. But it has different rules than anything I've ever worked on before. So it was really interesting. So I hope that answers a couple of your questions. You cannot put any kind of bypass capacitors or anything like that in the feedback circuit, because as soon as the feedback level gets above a certain level, the amplifier will oscillate. It's just the way it works. And when you have it set up correctly, nothing you do will make it oscillate. It's really odd. So anyway, I thought that would be an interesting thing to share with you. Just a 5-minute here clip. And again, we'll see you again real soon. And I will get the other side of the amp done, and we'll have something to actually test and do some actual signal testing next. Take care, everybody. Peace, joy, happiness, and good health in your lives. Bye-bye.